Hello guys, good afternoon. You are welcome to my YouTube channel, The Explicit Tutorials. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing Physics 111, a topic called Forced Damped Harmonic Oscillation. Now, before we go into solving problems, let me give us some keywords and formula we will need to tackle problems. Now, please take note, damped or undamped, all right? Damped or undamped system already have stored energy in them, which means that they do not need subsequent or supply of energy. So which means that when a damped or undamped system oscillates, all right, there is no supply of energy because they already have energy stored on the inside of them. However, during this oscillation, all right, the energy is lost exponentially, right? There's a reduction. The amplitude with which it uses to move reduces, okay? I told us the meaning of damping, and damping what? Oscillation. Just try to watch the video on chapter 2, okay? So you understand it better. Now, as soon as the energy reduces exponentially, all right, there's what we call decay vibration, all right? When the decay vibration, that is, as soon as there's oscillation, all right, the amplitude what reduces. This decay vibration, when it is what arrested, when it's arrested, look at the keyword. When this decay vibration is arrested, what is the impact of it to the system? It results what? Constant oscillations or constant oscillation. Okay, which means the process of arresting the decay vibration results in what? Constant oscillation. That is the impact of it. Now, for there to be constant oscillation, please, there must be the presence of what is called driving force, please. Driving force. All right, it is this driving force that maintains this constant what? Oscillation. It is this driving force that maintains what? This constant oscillation, which means that in the absence of driving force, there will be no what? Constant oscillation. Take note of that. Secondly, there's what we call frequency of natural oscillation. Frequency of natural oscillation. And okay, let me use this word, sorry. Let me use this word because these markers are bad. Natural frequency of an oscillator, and we have frequency of an impressed force. So take note of these two words: natural frequency of an oscillator and frequency of an impressed force. Okay, now listen. When the natural frequency of an oscillator is different from the frequency of an impressed force, I'll repeat. When the natural frequency of an oscillator is different from the frequency of an impressed force, what happens? The natural frequency of this oscillator dies off. As soon as it dies off, it begins to move or oscillate with what? Frequency of an impressed force. I recap. When the natural frequency of an oscillator is different from the frequency of an impressed force, what happens? It begins to what? Oscillate with the frequency of what? An impressed force. Now, this process will bring what is called maintaining what? Vibration. Maintaining vibration. All right, which means that a maintained type of vibration is called what? Forced vibration. Forced vibration. A maintained type of vibration is called what? Forced vibration, because the natural frequency of the oscillator is now moving with what? Frequency of an impressed force. So as such, the vibration is what? Maintained. Now this maintained vibration is called what? Forced vibration. A maintained type of vibration is called which of these? Forced vibration. Please do not forget that. That is case number one. All right. There's what we call resonance. Now, what brings about resonance? What brings about resonance or steady state? What brings about resonance or steady state? When the frequency of the driving force, we have frequency of the driving force, and frequency of natural force. We have frequency of the driving force and frequency of what? The natural force. Now, when the frequency of the driving force, I told that the driving force is what keeps the oscillation constant. When it coincides with the frequency of the natural force, it brings about what is called what? Resonance. It brings about this called what? Resonance or steady state. Steady what? State. I said when the frequency of the driving force coincides with the frequency of the natural force, what happens is what? Resonance, otherwise called what? Steady state. Which means that I can say that okay, how do I put it now? I can say that the driving force now, the driving force is denoted as P, alright, while the frequency of the natural force or the resonance force or resonance frequency, if I don't use the word frequency of natural force, I can use what? Resonant what? Frequency. Now resonant frequency is denoted as what? WR. Now please, in a resonance or steady state, in resonance or steady state, what happens? The driving force is always equal to the what? The resonance what? Frequency. The driving force is equals what? Resonance what? Resonance frequency. Which means that if this driving force is maybe 30, it means that the what? The resonance frequency is also called, is also what? 30. Because which means if the resonance frequency is 30, it means that the driving force is also what? 30. Now, what is the formula of resonance force or resonance frequency? Resonance frequency is given as the square root of the natural force or natural frequency minus W squared over 2. Alright, so this is the formula of what? Resonance what? Frequency. Resonance frequency. I told you that this sign represents what? Resonance frequency. Alright, I've told you that driving force is the P, and if the driving force is 30, it means that the resonance frequency is also what? 30. Do not forget that. So this natural frequency, which is WO, is given as what? K over what? M. K over what? M. So please, there's a square here, K over M. Why this this sign, I told us the meaning before. It means damped or damping force angular frequency. Alright, damping force angular what? Frequency. That's the name of this word, W square. And it is given as B over what? M. Is given as what? B over M. Km is force constant. M is what? mass, and B here means what? Damped force constant. Damped force constant, and M stands for what? Mass. Do not forget that. I've given us three formulas that we need to tackle questions. I told that at resonance, the driving force, which is P, is always equals to what? The resonance what? Frequency. Do not forget that. Where is the formula? So we have established that fact. Now that is natural frequency is equals what? K over M, while damping force angular frequency is equals what? B over M. So there's what we call general formula of damped oscillation. General formula of damped oscillation. General formula of damped oscillation. Now, in our previous class, I gave us that mx plus bx plus kx equals what? 0. Now, this formula is called what? Damped oscillation. Damped oscillation, okay? But this other formula, I have that mx plus bx plus kx equals force cos wt plus phase angle. Now, this formula is called what? Forced damped oscillation. Don't take one for the other. All right. This first one is what? Damped oscillation. But this other one is called what? Forced damped oscillation. So which means that this place is the mass, this one is the damped constant force, and this one is what? Force constant. Now I gave us just now that WO is equals what? K over what? M. Then I gave us that W squared is equals what? B over what? M. Which means to get a natural frequency, if this place was 10 and this place was 20, it would have been 20 over what? 10. And as for this, if this place was 5 and this place, okay, 10, it will be what? 5 over what? 10. It is very easy. So please take note of this formula. This one is called what? Forced damped oscillation, but this one is called what? Damped oscillation. Then I also give us a critical damped oscillation. I said B is equals 2 root Km. Right, this one is what? A critically damped system. Alright, so these are the formulas you must understand in physics 113. Alright, the ministry is still progressing, but just take note of this, and everything you have on the board. Okay, now there's what we call mechanical impedance. Mechanical impedance. Mechanical impedance. Mechanical impedance. Mechanical impedance. Mechanical impedance is denoted as what? Zm. Alright, mechanical impedance is denoted as what? Zm. Now, mechanical impedance is equals the square root of resistance plus mp minus k over p all squared. So this is a formula of what? Mechanical impedance. Mechanical what? Impedance. So this one is the resistance impedance, this one is the mass, and this one is of course the driving force, and this one is what? This one is also called what? Force constant. Do not forget. So this is, I've given us all the formula that we need in today's class. But however, there's what we call, there are two instances or two responses. We have the transient response, and we have the steady response. Okay, what do I do now? I'll rub off this. Now, I told you that in the steady response, the P is always equals to what? WRO, which is what? The resonance frequency. But in the transient in the transient states, the natural frequency oscillates and uh, die off by 1 slash nice decay time. All right. Right, the natural frequency oscillates and die off by decay what time. Do not forget that. But at steady states, all right, at steady state, driving force is always equal to what? The resonance what? Frequency. Do not forget that. So let's start solving questions. We don't have much to say regarding this except just what? Calculations. So after this topic, we'll be treating chapter 4, which is what? Wave. Now, there are exercises here which we are going to solve together. All right. The ministry is progressing. So I'll wrap off this. Let us start solving questions. So, exercise 3.1. They said the equation of motion of a particle of mass 2 kg is given by the equation of motion of a particle of mass 2 kg is given by 2x double dots then plus 4x single dots plus 7x equals 6 sine pi RT. 6 sine pi RT. Now, they said determine the resonance frequency. Determine the resonance frequency. Oh God. Determine the resonance frequency. It is very, very easy. Now, I gave us just now that resonance frequency is equals what? The square root of the natural frequency minus W squared over 2 all squared. I gave us this just now. However, I gave us that not to look for we to look for the natural frequency, which is this. We have to first look for the value of this and this. Now I gave us natural frequency as what? K over what? M. K over M. Do not forget the formula I wrote out just now. I said mx plus bx, okay, single dots, plus kx equals what? 0. Which means that m here is what? The mass, right? And 4 is the b, and 7 is what? K, all right? I told us that k, that is natural frequency, is what? K over what? M. Now from here, it means that we are going to be having 7 over mass, which is what? 2. And that will give us 3.5. 3.5 rad per what? Second. I believe that is correct. That is 7 divided by 2. 3.5. It is very, very correct. Now for you to look for this, I told you this what? B over what? M. B from the question, look at it here. B, which is 4. Then M is what? 2. So I now have what? 2 rad per what? Second. Okay. Now we've been able to get the value of natural frequency and the damp force angular what? Frequency. Therefore the resonance frequency now, which is WR, is equals, here we had 3.5, which is alright, 3.5 minus, we had 2, right? So 2 all squared over 2. So natural resonance is equals 35, okay, 3.5 minus, all right, 2 raised to power 2 is what? 4. That's 2 times 2, 4. 4 divided by 2 is what? 2. So what do I have? 3.5 minus 2, I'll have 1.5. So it's equals what? 1.5. 1.5. But we have to look for the square root of 1.5. 1.5. Square root of 1.5. The square root of 1.5 is 1.22. 1.22. All right, and I think we have the answer to be A, rad per second. All right, so the answer here is what? 1.22, which means that the answer is what? A. All right, so that is for that. Just follow it bit by bit. Write out the formula. Since we were not given this and this, we use this natural frequency and this other one. Whatever you get, put it into it and you start solving gently, and what? Gently. So we have solved question 1. So let's solve question 2. It is very, very easy. Let's solve question 2. I'm leaving that one for reference sake. All right, they said the equation of motion of a particle is given as 2x double dots plus 4x single dots plus 7x equals 6 sine pi RT minus phase angle minus what? Phase angle. All right, so let's do this. Now they said the maximum displacement of the part of the periodic motion is obtained when the parameter r takes the value we don't know now. All right, so don't forget the first thing we do. R is equals natural frequency minus w squared all squared over what? 2. That is the formula, isn't it? So for you to look for natural frequency is going to be k over m as initially given. K here is what? 7 and m is what? 2, and that is 3.5 rad per meter second. Then w squared is equals b over m, and b is 4, m is what? 2, and that will give us what? 2 rad per meter second. We have to look for the value of what? Resonance frequency. Resonance what? Frequency. All right, so in doing that, I think we are going to be having the same value as the first one. Yes, we had our R to be what? 1.22 rad per meter second, but that is not what we are looking for. Now, looking at the formula that I wrote out, I said that we have mx plus bx plus kx, right, equals cos pt plus what? Angular what? Or phase angle. Now looking at what we have there, pt is is occupying this position, is occupying that position. So what do we do? Here's the cover. Now, which means we are going to be comparing. In doing that, we'll write out, we'll say pt is equals, excuse me, let me check. Hope it's recording. Yeah. We'll say pt is equals what we have here. Where is it? As pi r what? T. I think this 2 now cancel out this t. I know that p is equals what? Pi r. Okay, but they said the parameter r takes the value, so which means we'll make r the subjects of the formula. In doing that, we divide both sides by pi. So this will go into this. It means that pi therefore is equals, okay, it means that p therefore, is it p therefore now? No. That's arrow therefore is equals what? P over what? Pi. P over pi. Now I told you that at resonance, P is equals what? Resonance what? Frequency. Alright? So it means that if W arrow is 1.22, it means that P is also what? 1.22. Therefore, now it will be 1.22 divided by 3.143. It is 3.143 because the value of pi is 22 over 7. That is, you now divide it, you now have what? 3.142. So you approximate, you now have 3.143. So let's divide. So 1.22 divided by 3.143 equals 0. I have 0.388. What did they get? 388. Okay, they got 3899. 3899, which is very, very what? Correct. So we are done. So that is a value of what? Arrow, which means that therefore arrow is equals to what? 0.388 what? Hertz. 388 hertz. Okay, wait, I think I had 2. Let me check if I'll get the same thing. No, I approximated. Wait. 1.22 divided by 3.142 equals, okay, 0.388. The same thing. Alright, so the answer is what? 0.388, just as they got. So that is exercise 3.2. Now let us take the next one, which is exercise 3.3. Exercise 3.3. So I'll rub off this one. I believe it's going well. Just follow it step by step. You understand it. I'll leave the formula because we've been asked to calculate for the same thing again. Arrow. We have to look for the value of arrow. So I'll leave that on the board as well. So let me see the value they give us here. Okay, 3. So I'll remove these ones. Then they said 5 cos theta. So I'll remove this one. Then they said pi arrow t minus, okay, plus phase angle. So they said the equation of motion of a point mass, you have 3x, you have 5x, and you have 12x, then equals 5 cos, then pi arrow t plus what? Phase angle. Okay, plus phase angle. Now they said find the value of arrow at maximum displacement of what? The particle. It is easy peasy. The same procedure is required. The same procedure is what? Required. So in doing that, K, where's occupying the position of K? 12. You now have 12 over, then what about M? 3. And that will give us what? 4 rad per waiting second. 4 rad per waiting second. What is occupying the position of B? Is 3. Okay, B, 5, sorry, 5. Then M is what? 3. So 5 divided by 3 is what? 5 divided by 3 equals 1.67. 1.67. Now for us to calculate for the resonance frequency, what do? We substitute, which means that W arrow is equals the square root of 1.67 minus 4. Yeah, natural frequency is 4. Then minus 1.67 squared over what? 2. So let's do it. 1.67 squared, sorry, 1.67 squared equals 2.7, that is 2.7889. 2.7889 what? 9 divided by 2. 2.7889 divided by 2 equals 1 point. Therefore, now the resonance frequency is equals 4 minus 1.39. Okay, 39. All right, 39. Therefore, let's subtract and do the square roots. Okay, so 4 minus 1.39 equals 2.61. 2 point. I will equal the square root of 2.61. Now let's look at the square root of 2.61. Square root 2.61 equals 1 W arrow is equals 1.6155. 1.6155. Is that the final answer? No, that is not the final answer. So what do we do next? They're asking us to look for the value of what? Arrow. Now I told us that if W arrow is this, it means that P is also what? 1.6115. So let's do it. Which means that arrow now is equals what? 1.6155 over 3.143 over 3.143. So let's divide 1.6155 divided by 3.1143 equals 0. Arrow is equal 0.513. Okay, 514 hertz. All right, what did they get? They got 0. I don't understand. What is the name of that? What is the meaning of that? .514. Okay. So the answer is they had 0.514. So it's the same. Okay, it is very, very correct. I was wondering. So which means that the value of arrow in this question is what? 0.514 hertz. That is how it is. Now, the next one is what? 3.4. The equation of motion of a point is given as 3x plus 7x plus 11x is equals 20 sine 12t plus phase angle. Find the resonance frequency. Find the resonance frequency. The same process is required here. So I'll rub off this one as well as this. So let me leave that for now. So K from the question is 11. All right, 11. And Km, and you have M to the what? 3. So 11 divided by 3. 11 divided by 3 equals 3.67. Now B is what? B, 7 over 3. 7 divided by 3 equals 2.33. 2.33. It therefore means that our resonance frequency is equals Now we got our natural frequency as what? 3.67 minus W squared, we had it to be 2.33. It's 2.33 all squared divided by what? 2. So 2.33 square equals 5.4289. 5.4289 divided by 2 equals 2.71. Okay, so WR now is equals 3.67 minus 2.71445. Do not forget square roots. So you have therefore WR. This marker is not good enough. So let's subtract 3.67 minus 2.71445 equals 0.9555. Now, what is the square root of 0.95555 equals, so W, oh god, sorry, these markers are bad already. So resonant frequency now is equals what? 0.9, okay, 977. What did they get? What did they get as their answer? 0.971. Okay, 0.971 is very, very correct. So please just follow it step by step and you understand it properly. Now, this one is somehow tactical. It's tactical, but we can actually do justice to it. Then as for 3.6, which is very, very simple, I'll leave it for us to solve, okay? I'll leave it for us to solve. All right. Let me rub off this one as well, because we are done for today. So, it said the equation of motion of a particle is given by F plus 6x plus 27x equals what? 5 sine WT plus what? Phase angle. Phase angle. What are they asking us to do? Determine the type of motion and determine the frequency at a steady state. Now, at a steady state, I told that P is always equals to what? Resonance what? Frequency. Alright? And you know that frequency is equals what? P over what? 2 pi. I told that resonance that is frequency. Okay, it's like I did not give you this formula. Like F is equals what? P over what? 2 pi. So it means that F is equals, wherever I see my P, I'll put what? W arrow, which means that W arrow, okay, over what? 2 pi. Right, so W arrow here stands for resonant frequency, and I believe that is what, just substitute F, the frequency of a damped oscillation is given as this, all right, and you have P at resonance, you have P equals what? W arrow, which means that wherever you see your P, you put this and you have this. I believe that is what they got here. Yeah, that is the answer. So at this point, we'll call it a day. Please make sure you subscribe to my YouTube channel and share to your friends who are in need of this topic. Thanks for watching. Do have a wonderful day.